Today, we are going to cover the general properties of waves. This will include transverse and longitudinal wave types, and the waves which fall into the two categories, while also covering the basic wave equations. Waves transfer energy while transferring matter. This is a definition of a wave. All waves transfer energy by oscillating and vibrating, basically moving back and forth. There are two basic wave types, transverse and longitudinal waves. Transverse waves oscillate or vibrate perpendicular or at right angles to the direction of propagation or the direction of energy transfer, where the energy is headed. You can think of it as two people whipping a rope up and down, holding it from opposite ends. Longitudinal waves a little bit different. Longitudinal waves oscillate, vibrates, parallel to the direction of propagation or the direction of energy transfer, where the energy is headed. You can think of it as a spring contracting and relaxing. Now that you understand the difference between the two, let's give some example for each. Here are some transverse waves. Just remember, electromagnetic waves, water waves, and seismic S waves, secondary. They are transverse. For longitudinal, just remember, only sound waves and seismic P waves, primary. This is the general diagram of a transverse wave. Here is the amplitude, or the displacement from the midpoint. This is the trough, it is the minimum point. This is the crest, it is the maximum point on the wave. This is the wavelength, the distance between the same point on two consecutive waves, or the distance between crests or troughs. This is measured in meters. To find the wave speed, or how fast the wave is moving, you can do V equals F lambda, or wave speed equals frequency multiplied by wavelength, lambda. The frequency is the number of waves that occur in a time period. Think of it as waves per second, but the units are hertz. This is the time period. It is the amount of time taken for one complete wave to occur. The units is in seconds. There is also another equation. F equals 1 over t, or frequency equals 1 over time period. We can also manipulate the equation to find the time period. So we can say time period equals 1 over frequency. T equals 1 over f. So the greater the time, the less frequency, vice versa. They are inversely proportional. Here are some questions to test your understanding. If a wave took 2 seconds for one oscillation, what is its frequency? Pause the video and have a try. So this is pretty easy. Just use the equation F equals 1 over t. F would equal 1 over 2, or 0.5 hertz. Let's do a harder one. If we have a wave that took X seconds for 4 complete oscillations and the frequency is 200 hertz, what is the time period for one complete oscillation? Pause the video and have a try. This one is harder. First, set up the equation. Time period for one wave must be X divided by 4. And F equals 1 over t, frequency and time period. So 200 equals 1 over X divided by 4. Let's put X on its own. First, times both sides by X over 4. So now it would become 200X divided by 4 equals 1. Times both sides by 4, 200x equals 4. Divide both sides by 200, so you get x equals 4 over 200, or 0.02. We are not done now, since x is the time taken for 4 oscillations, but we want only 1. So we divide the x value by 4, and we get the answer of 0.02 divided by 4 equals 0.005 seconds. Now let's move on to the wave speed questions. If a wavelength is 4 meters and the frequency is 4 hertz, what is the speed? Have a pause and go. This should be straightforward. V equals F lambda. V equals 4 times 4, or V equals 16 meters per second. Now to end it all, let's do a question with both equations combined. If the time period is 4 and the wavelength is 7, what is the wave speed? Pause the video and try. Just find 2 out of 3 for the wave equation, and you can find the last one. F equals 1 over t, so F equals 1 over the time period 4, or 0.25 hertz. V equals F lambda, so V equals 0.25 the frequency times the wavelength, which is 7. Therefore, V equals 1.75 meters per second. This is our first video. Subscribe if you find this helpful. Bye.